Hello, my name is Ryan Kinchin. I'm with High Desert Math Tutor, and today I want to take a moment to introduce the concept of limits to you. So this is a conceptual introduction. I just want to get the point across of what the idea is behind limits, and then other videos will follow that will get more into the details of computing limits in different scenarios and the difference between algebraic interpretations versus how you approach limits for geometry, algebra, just anything of that nature. So what is a limit? So a limit is the idea that you continue to move towards something. So you can move towards numbers, you can move towards infinity, which is an idea. So limits signify movement. So anytime you think of limits, you should think something is moving. We're moving towards something. So here, I have a small graphical example of a limit that we'll be considering. But to write this in limit notation, we could say the limit of f of x, notice this blue graph is called f of x, the limit of f of x as x approaches the number 3. So the idea here is that we're moving towards the number 3 from the left, and we're moving towards the number 3, the x value 3, from the right. But when we're doing this, we're actually following along the graph. So limits are really only concerned within a very small range or distance around the number that we're approaching, which in this case is 3. So in the neighborhood of 3, this function has a certain point that we're tending towards. And the idea for us is, as this function approaches x equals 3, we want to know what y value is the graph approaching. Now notice right here, it may be a little hard to see, but there's actually a hole when x is 3. So you see, there's no actual point for this function at x equals 3. So we need to find another mathematical way to express the idea of where the graph is tending towards as x approaches 3. So the idea here is the limit signifies movement. The limit of this function, where are we moving towards along this function as x approaches 3? So the answer to a limit is the y value that we're tending towards. So as x approaches 3 from the left and from the right, we see that the y value that we're tending toward, there's no y value here, but the one we're tending towards is y equals 2. So this limit of f of x as x approaches 3 equals 2. So the purpose for having limits, as we see here, limits are useful when you're approaching a certain number that you're not allowed to touch. So we cannot say f of 3. We cannot plug the x value 3 into f of x, because if you look at the graph, you see that there's a hole at x equals 3. So this function is undefined at x equals 3. So what we say is f of 3 is undefined. But we don't want to let individual points that are undefined stop us from making progress when we're working through problems. And all of calculus is built using limits. We constructed calculus in a way where we're constantly dancing around the idea of something being undefined. And to combat that, we had to formalize the idea that even if we cannot simply be at this point, we can ask what's happening infinitely close to this point. So that's the idea of limits. Limits is all about movement. It's all about understanding functions near points that are typically undefined.